I guess maybe if it's, you go to another school. But that just sounds like probably not worth the effort. Okay. All right, so chapter 12. This is our last, I guess our last chapter of like actual material. And this is on correlation and linear regression. And so so far, let's just talk about all of these other things that we have, all of these other statistical tests that we have learned about, right? So, you know, we have a t-test for independent groups. So let's just, I'll call this review of other tests. Okay, so we have a t-test for independent groups. And when do we use that? Maybe I shouldn't ask such such questions here. Okay, well, I will tell you. We use the t-test for independent groups to see if a numeric variable has different means for two different groups, right? So basically, you know, is a numeric variable almost, here, I'll just kind of summarize this. This might not be the best way to go about, but we'll say, you know, is there a relationship between a numeric variable and a categorical variable? Okay, this is one way to say this is kind of the purpose of this test. Like, you want to know, is the numeric variable is I don't know, prothrombin time, whatever, is that different when people take one drug versus another drug? Or is, you know, does this thing is this value different for this group versus this group? Okay, so you have a categorical variable which splits the observations into two groups, and then you want to know, is there a relationship between those? Okay, and others that kind of go along with this, Wilcox and Mann-Whitney also tests is there a relationship between a numeric variable and a categorical variable. And even one-way ANOVA tests to see, is there a relationship between a numeric variable and a categorical variable. Okay. So these all go into, is there a relationship between a numeric variable and a categorical variable? Okay. We have the chi-squared tests. Okay, and the chi-squared tests for independence asks, is there a relationship between two categorical variables? And then lastly, okay, and then so today we're going to cover correlation and linear regression. And this asks, is there a relationship? What do you think? Between?
Two variables.
Well, between what kind of variables? Between two numeric variables, exactly. You are so smart. Okay. Okay? So is there a relationship between two numeric variables? That's what we're going for, okay? So this is, and I'll kind of map this out next week when we do a review of all of the stuff we've covered. There is one more test, I guess. I shouldn't say there's one more test. There's lots of other statistical tests, but as far as kind of in this theme of like seeing if there's a relationship between different kinds of variables, there's one where you have a categorical response and a numeric predictor, and that one is logistic regression, and we just won't have time to cover that in our course. Shucks, right? If it was a semester-long course, maybe we would. But that's what we get. Okay, so so we have this. Is there a relationship between two numeric variables? Okay, so let me pull up our text, and I'm going to copy a table of data. Here it is. Okay, so this is, we've got two numeric variables. Okay, they are the length and the weight, and this is taken from, I guess, like a bunch of snakes. Okay, so we've taken, we took a snake and we measured how long is this snake. Okay, so this is my picture of a snake, and we say, okay, how long is the snake? Okay, so all right, I don't know why I'm drawing this. Okay, this, just in case you didn't know, this is how we measure length, and then we put it on a scale. Okay, and we get the weight. All right. All right, and so we measured how long is the snake, how much does the snake weigh, and we want to know, is there a relationship between the length of a snake and its weight? Okay, and this is all for the same species of snake. Okay, so it's all snakes of one species. We're not talking about, like, I don't know, different species. Huh? It is. This is, we put the snake here. What? It's just remind. Have you guys seen like what is this a picture of? Have you guys read The Little Prince? No. Okay. So this is people say it's a hat. Huh? No, it's a snake that swallowed an elephant. I can't draw an elephant in here, but all right, okay. Little Prince, excellent book by whatever, that French guy. Have you read it? No.
You've heard of it.
You've heard it. Something, yeah, The Little Prince. Okay, that's not your homework, but homework for life, okay? Yeah, I think they're making a movie too. All right, okay, so we're gonna create a scatter plot here. So 6, 7, 8, 9, 60, 1, 2, 3, 4, 5, 6, 7, 8, 9, 70. Okay. And then as far as the weight goes, we'll start off at 90, 100, 10, 20, 30. Okay, and then I'm just gonna graph these, right? So we're going to say this one, 60 and 136, right? Somewhere around there. 69 and 198. Oops. Somewhere like right there. And 66 and 194, something like that. 64 and 140. I'm just kind of eyeballing these. 54 and 93, get a dot. 67 and 172. And 59 and 116. 65 and 174. And 63 and 145. Okay, this is what we have. All right, and we just ask, is there a relationship between the length of a snake and its weight? Okay, and we would say yes. All right, snakes that are longer than average weigh more than, or I would say tend to weigh more than average. And we'll say snakes that are shorter than average tend to weigh less than average. Okay. And so this kind of relationship, this is known as having a positive relationship. So a positive relationship is defined by the trait that large values of x, large x goes with large y, and small x goes with small y. Okay, and this is not like an exact thing, but just kind of like the overall trend. Okay, and that's what we see. As far as length goes, the long snakes, the longer snakes were like 69 centimeters long. I guess that's like a little bit over 2 feet as far as these things go. Okay, and they were the heavier snakes. Okay, the long snakes were the heavy ones, and then in general the shorter snakes weighed less. So that's kind of our overall trend. So we would call this a positive relationship. Okay. So what would a negative relationship? So a negative relationship, we would say large x goes with small y, and small x goes with large y. Okay, and again, overall trend. So of course, not everyone's going to fit the exact trend, but overall, you have something that kind of looks like this. So as x gets bigger, the large values of x correspond to low values of y, and the low values of x go with the large values of y.
So that's basically just observing the slope, then, right?
we're not talking about slope. We're just talking about this is called the direction. So yeah, you know, it's I guess it's fair to say that, you know, in general, or not in general, you know, positive relationship, if positive, and I'll have to say positive linear relationship looks like this, and then, you know, negative linear relationship would look like this, okay? You know, your data points scattered along, something like that, okay? So yeah, so part of describing a relationship between two numeric variables is the direction, okay? So this aspect is called the direction, and it's either positive or negative or neither. Positive, negative, or neither, okay? We can talk about the shape of a relationship, okay? And as far as shape goes, we will concern ourselves either with linear relationships, which means a straight line can be used to summarize the relationship. Okay, and then everything else we're going to call nonlinear relationships. So if a straight line can't be used, we're going to call it nonlinear. Now, if you take a course devoted to the topic of regression, then you'll probably get into all of the other shapes that exist, you know, quadratic relationships and exponential relationships and things of that nature. But you know, we're spending 1 week on this topic, whereas, you know, you could take an entire course devoted to regression, okay? So that's linear relationships, and then if we're not talking linear relationships, we'll just say nonlinear relationships. Okay, which means a straight line will be insufficient or will not do a good job. Okay. Now, as far as how do we tell if a relationship is linear or nonlinear? As far as we're going to go in this class, we're just going to use our eyes, okay? We're not going to bother, you know, statistical tests exist, but they're just okay at this thing. You know, our eyes have, and our brains have, I don't know, like, we're very good at detecting patterns and seeing if a straight line relationship exists or not, okay? So, you know, our brain and our image processing abilities are very good, okay? And so we can detect patterns and say, hey, you know, something like this, yeah, that looks like a straight line can describe the relationship, okay? So this would be linear. Okay, whereas something something like this, we would probably, you know, if we had to kind of fit something, maybe we'd say something like this. I don't know, who knows? So this would be nonlinear. Okay, so basically, you know, what is linear and what is nonlinear? Basically, the advice is always create a scatter plot, okay? Always make a scatter plot first. And then just look. Does it look like a straight line could fit? Okay, and it's true. You can ask two different people, and one might say, I think a straight line could work, and someone else will say, I don't really think a straight line could work. And they're probably both kind of right, okay? Because it's probably a data set that is kind of in between what is obviously a straight line and what's obviously not a straight line. And so that could happen as well. Okay, so we've got the direction, we've got the shape, okay? And then we also have the strength of a relationship. Strength of a relationship between two numeric variables. Okay. And so the strength of a relationship, this is kind of the, we can summarize this concept as how much scatter exists in our plot, okay? The kind of the idea is how much scatter exists in the plot. Or another idea is if I know one variable, if we know know one of these variables, can we make good predictions about the other variable? If we know the value for one variable, so if we know the value of, for one variable, can we make good predictions about the other variable? Okay, and so we would have something like, if you have, even if I get rid of this straight line here, okay, let's say your data looks something like this. Okay, and I said, okay, I'm going to give you, here's a, you've got some value x right here. What is your prediction for y? Okay, so if you're given a value x right here, basically your prediction for y is going to be kind of in this range here. Okay, do we agree there? Okay, so this is kind of the range of y of our prediction. Okay, so the range of our prediction for y. Okay, so this, we would have a very strong relationship between x and y because this is a pretty tight region. Okay, so it's a small range, so we can make pretty good predictions. Okay. Predictions of y based on x. Okay, so we would say strong relationship between x and y. Okay. On the other hand, So overall, yes, there is a positive, overall there is a positive relationship. Okay, so that's true. But let's say I said, okay, here's your next x value, okay? Kind of where are we going to say, we're going to basically say y can be anywhere from here to here, okay? Our range of possible y values, you got this huge, kind of this large range of what y could be. Okay, so our predictions of y will not be very strong here. Or it will not be very good. So as far as the relationship between x and y, we will say, you know, we have a weaker relationship. Between x and y. Okay, and so so let's just maybe talk a few examples here. Okay, so you tell me, is the relationship, is it going to be positive or negative? And then we'll say, do you think there's a strong or a weak, or I mean, you could even say like medium, medium relationship, okay? Okay, so we would need two numeric variables. Okay, so we'll say variable 1 will be the someone's height, a person's height, okay, and the person's pants inseam. Okay, so this will be x, and this will be y. Okay, so what do you think?
Positive and strong.
Positive and strong, right? So we would expect tall people to have large pants inseams, okay, and we expect the relationship here to be quite strong, okay. So so this will be positive and strong. Is that okay with everybody? Okay. What if we do a person's height and the person's weight?
Positive and medium.
Okay, yeah, I would say positive and medium. Positive and medium, okay? So it's not going to be totally weak. We will see some kind of positive thing, but the relationship is not as strong, okay? Because just someone who's tall is probably going to weigh higher than average. So someone who's very tall, so very much above average, is probably going to weigh more than average overall. So that's going to give the positive relationship. But can you make very good predictions about someone's weight knowing just that person's height? Probably not. Probably not. Okay? On the other hand, a person's height, sorry, not a person's height, a person's waist size correlates very strongly with the person's weight. Okay? So this would be positive and strong. Okay. Okay, what about some other things? Let me just try to think of things here. Okay, altitude and air pressure. So like, I guess a city's altitude, or, you know, I don't know. You don't like this example? Are we not familiar with this concept?
Isn't it negative and strong?
So cities with high altitude, so we'll talk about cities. So cities with high altitude, do they have high air pressure or low air pressure? Do we have no idea what we're talking about? They have low air pressure, right? And cities with lower altitude would experience greater air pressure. Okay, so we would have a negative relationship. So a negative relationship. Can we make good or poor, would our predictions be good or bad if we know the altitude? Huh?
Good, right?
We would be able to make good predictions about the air pressure, okay? In general, like if you know the city is at this altitude, and you can pretty much predict the air pressure there fairly well, okay? Of course, you know, I guess from day to day, the pressure could change a little bit, but not very much, okay? So this would be a strong relationship. Okay, we'll say, what about cars? Okay, maybe we'll say used Honda Civics. Okay, so this will be our population. We'll say the mileage and the resale price.
Negative, strong.
Negative, yeah, probably strong or medium to strong, I would say. I don't know. This is it depends, right? Because there's a lot of other factors that go into determining the sale price. The mileage is probably the biggest one that goes into determining the sale price, but there's a lot of other things. Well, I mean, probably the biggest one will be like exterior damage, but things like that. Okay, so anyway, we get the general sense here. Okay. As far as linear relationships go, okay, so for linear relationships, okay, there is a summary statistic that, you know, basically gives a numeric value to the direction and strength of a linear relationship. Okay. Okay. And so this value is called the correlation. Okay, so we have correlation, and it's given by the symbol R, kind of like relationship. Okay, and basically R can be any value between -1 and +1. Inclusive. All right. If R is positive, so basically the sign of R is the direction of the relationship. Okay, so if R is positive, the relationship is positive. If R is negative, the relationship is negative. Okay? And if R is close to 0, the relationship is weak. Okay? And so close to 0 is, I would say, you know, R is between, you know, minus 0.35 to plus 0.35, or even like 0.4 even, okay? So anything I would say between, you know, so this I would say is close to 0, okay? And if R is far from 0, and the relationship is strong. Okay? And depending on the context, we'll decide whether the relationship, what is determined to be far from 0. Okay? So if you're talking about robots, you would expect your R to be over 0.9 almost all the time. Okay? Machines, you'd expect R being quite high. If you're talking about people, you'd get very excited, and you'd say, you know, there's a strong relationship when R is something like 0.6 or something like that. Okay? Because people are a lot more unpredictable than machines. Okay? Okay. So, you know, kind of, we have this nice summary diagram in the textbook that I would rather just copy over. So here we go. Okay, so we can look at this. And so we can see, you know, when your points are just kind of like this, where you'd say there's neither a positive nor a negative relationship, and the relationship's very weak, the R is 0, okay? And over here, you've got a lot of scatter, right? Overall, it's a negative relationship, but the relationship is quite weak, so we would say R is negative 0.4. As the amount of scatter gets smaller and smaller, here we've got, you know, a stronger relationship of negative 0.8, okay? And then when they line up perfectly in a straight line, then you have a correlation of negative 1, okay? So when R is 1 or negative 1, when R equals minus 1, you have a straight line, a perfect straight line. And then R equal to plus 1, you also have a perfect straight line, okay? Okay, and so we kind of have this spectrum of anything going from negative 0.8 to, or, you know, from positive 1 to negative 1, okay? Now notice these two both have, both of these have R's of plus 1, okay? And the slopes are different, okay? But R doesn't tell us about the slope. It just tells us about the relationship, the direction and the strength of the relationship. So as far as the direction and the strength of the relationship go, they both form perfect straight lines. You can make very good predictions about one variable from the other. So you're going to have R equal to plus 1, okay? And they're both in the positive direction. Does that make sense? Okay, so So the slope doesn't matter, you know, this one's more steep and this one is less steep, but you both have r equal to +1, okay? This one is neither positive nor negative, so you have r equal to 0. Okay, it's a straight line, but it's neither positive nor negative, okay? And it also makes sense, right? In this case, what's going on, is there a relationship between x and y? No, because y is just constant. No matter what x is, y is going to be the same value. Okay, so y doesn't depend on x, it's just the same for everybody, okay? So here, you know, no relationship. Y is the same for everyone, okay? And then here we just have other things that are nonlinear, having overall correlation is 0, okay? These interpretations of R being strong or weak, positive or negative, these only work when the relationship is linear, okay? Okay, and so, but R is just a formula, okay? Is just the result of a formula. Okay, so you can just throw any points, even if it's a nonlinear relationship, and you're going to get a value for R, okay? R is just the result of a formula. You can plug in any set of points and get a value for R. Okay. But that does not mean you have a linear relationship, okay? But R cannot tell you if you have a linear relationship. Okay, so for example, you know, you might see R is equal to plus 0.95, and you might be tempted to say, oh, we've got a positive, strong linear relationship. But that's not the case, okay? Okay, you may want to say positive, strong, linear relationship. Okay, but it may not be, okay? Because I'm pretty sure if I have a data set that looks like this, okay, I will get something like R equal to plus 0.95. Okay, something like this will, I think, give me R equal to plus 0.95, but this is not a positive, strong linear relationship. Okay, so how do we tell if something is a linear relationship or not? No, we just make a scatter plot and look at it. Okay, so make a scatter plot, look at it. If it looks like a straight line to you, great. If it doesn't look like a straight line, so I hope you would look at this and say, well, that doesn't look like a straight line. Okay, and then so if it doesn't look like a straight line, you'd say it's not a linear relationship, and there you go. All right, why don't we take a short break? I know it's just one chapter, but we still got a good amount to cover. So we'll take a short break here, and then and we'll come back and we'll keep talking about